This is the answer to problem number 14 on the kinematics review problems. A car is traveling at a constant speed of 33 meters per second on a highway, so that's going to be car number 1. At the instant the car passes an entrance ramp, a second car enters the highway from the ramp. The second car starts from rest, so that's car number 2 with an initial speed of nothing. And it has a constant acceleration. We don't know what that constant acceleration is. What acceleration must the car have, that's car number 2, so that the two cars meet again for the first time at the next exit 2.5 kilometers away, or 2,500 meters. So they both are going the exact same distance of 2,500 meters. So if we just try to solve for the acceleration of car 2, we say, okay, we're going to pick the equation without time in it, or we're going to pick the equation without velocity in it, but the final velocity. But the problem is we have two unknowns. We can only have one unknown. If we have two unknowns, we cannot solve directly. We have a problem. But that's okay. We can fix it. We know that car 1 is going to go the same distance as car 2. They both go 2.5 kilometers or 2,500 meters. So we know how long it's going to take car 1, or at least we can find how long it's going to take car 1 to get to that next exit, because we know how fast it's going, and this is constant velocity motion, which is d equals v times t. This is actually right here, this constant velocity equation, the same equation as the one we're going to use for car number 2 later, d equals v times t. Now the reason why there's no 1/2 at squared is this car is not accelerating. So when you plug in a 0 for acceleration, 1/2 times 0 times t, it goes away, leaving us with just d equals v times t. So this equation actually is one of the kinematics equations. It's just simplified for you, knowing that acceleration is 0. So we're going to solve for time. Time is going to be d divided by v, because we're going to divide the v over to the left, giving us 2,500 meters divided by 33 meters per second for a total time of 75.76 seconds. Now we know that car 2 has to travel the exact same amount of time, because if it traveled any longer or any shorter to get to that spot, it wouldn't be right next to car 1, which is what the problem is asking. So we now know the time, 75.76 seconds, so we can pick the equation without VF in it. That's d equals v naught t plus 1/2 at squared. We're solving for a, so we're going to subtract the v naught t term over to the left side first, which is why we have d minus v naught t, and then we're going to divide by 1/2 t squared. That's why that's in the denominator, and now we can plug our numbers in. 2,500 meters minus 0 times 75.76, that whole term just goes away, divided by 1/2 times 75.6 squared gives us 0.87 meters per second squared for the acceleration of car 2.